Assalamualaikum, we are from Group 6 and our topic is Unit 6, Inverters, DC to AC converters. The group members are Muhammad Nusaifan bin Saidin and Nur Syahira binti Nurulizam. The subtopic is pulse width modulation techniques and also pulse width modulation inverters. The pulse width modulation technique that can also be called as PWM. The output of DC voltage of most inverters application requires some way to be controlled. In PWM, the output voltage is a pulse width modulated wave, and the average output voltage can be controlled by varying the duration of the switch's turn-on time. Along with many other use, PWM main purpose is to actually control the power that's supplied to various types of electrical device, most especially to initial loads such as AC or DC motors. There are got three most commonly used methods for the pulse width modulation technique. The methods are multiply pulse width modulation, single pulse width modulation, and also sinusoidal pulse width modulation, which can also be called as SPWM. The single pulse width modulation. The output voltage waveform in this voltage control method is a single pulse. In each of the output voltage is half cycle. The frequency of period T is a signal is equal to the frequency of the signal. The AC output voltage may be controlled by varying the pulse width. By creating from the three basic states in approach switching reaction, such as state 1, Q1 and Q4 equal to on, and states 2, Q2 and Q3 equal to on, and stage 3 is Q1 and Q3 equal to on. Then is the multiply pulse width modulation. Rather than changing of the pulse width to regulate the output voltage, the inverter's output may be rapidly turned on and off many times within a cycle to generate a continuous stream of pulse. Multiply pulse width modulation is seen in the next figure. There is m pulse per half circle of the desired output voltage in the output voltage waveform. If f the output frequency of the inverter, then the frequency of the pulse Fp is given by Fp equal to 2mf. Therefore, the number of the pulse per cycle is 2m equal to Fp per f. And next is sinusoidal pulse width modulation, SPWM. The output voltage is regulated in sinusoidal pulse width modulation by varying the on-off periods. Therefore, the pulse width is longer at the peak of sine wave during on the periods. The general PWM pattern is as shown as the figure that you can see below. A reference signal, VR, is a sinusoidal wave with amplitude VR and frequency that is set equal to the desired output frequency of the inverter to accomplish the appropriate switching timing. The carrier signal VC has a frequency of C and an amplitude of VC. The junction of VR and VC wave determine the switching sites. The time during which on the turn-on pulse is determined. The first is VR is larger than VC in the positive half circle of VR, and the next is VR is lesser than VC in the negative half circle of VR. As you can see, the two control parameters that regulate the output voltage are chopping carrier ratio and modulation index. The modulation index determines the width of the pulse, therefore the RMS value and the inverter value, whereas the chopping carrier ratio determines the number of pulses in each cycle of inverter output voltage. M is usually adjusted by varying the FR. By altering the amplitude of the reference voltage VR, it will be affect the effective value of the output waveform and varying the pulse width.
Okay, Assalamualaikum. I will present about pulse width modulated inverters. And inverters whose functionality depends upon the pulse width modulation technology is referred to as PWM inverters. These are capable of maintaining the output voltage as the rate voltage depending on the country irrespective of the type of load connected. This can be achieved by changing the switching frequency width at the oscillator. Then there are several circuit topologies and control methods used to convert a DC input into a three-phase AC output. A common circuit topology is a voltage source inverter, which is shown in figure PWM1. The inverter is fed by a DC voltage and has three phase legs, each consisting of two transistors and two diodes labeled with subclass. Then a common inverter control method convert inputs beginning undergraduate and graduate power electronics of machines caused in sine triangle pulse width modulation is STPWM control. Then with STPWM control, the switch of the inverter are controlled based on a comparison of a sinusoidal control signal and a triangular switching signal. The sinusoidal control waveform establish the desired fundamental frequency of the inverter output, while the triangular waveform establishes the switching frequency of the inverter. The ratio between the frequencies of the triangle wave and the sinusoid is referred to as the modulation frequency ratio. Okay, this is sinusoidal PWM is a typical PWM technique. In the PWM technique, the AC voltage reference VRF is compared with the high frequency triangular carrier wave VC in real time to determine switching state for each pole in the inverter. Then by controlling the switch in the manner the line to line inverter output voltage are AC, with a fundamental frequency corresponding to the frequency of the sinusoidal control voltage. In most instances, the magnitude of the triangle wave is held fixed. The amplitude of the inverter output voltage is therefore controlled by adjusting the amplitude of the sinusoidal control voltage. The ratio of the amplitude of the sinusoidal waveform relative to the amplitude of the triangle wave is the amplitude modulation ratio. In systems in which the inverter source inductive loads, the inverter must source power in all four quadrants. The diode provides path for current when a transistor is gate on but cannot conduct the polarity of the load current. For example, if the load current is negative at the instant the upper transistor is gate on, the diode in parallel with the upper transistor will conduct until the load current becomes positive, at which time the upper transistor will begin to conduct. Okay, this is block diagram. First, with modulated inverters. Pulse width modulation of or PWM technology is used in inverter to give a steady output voltage of 230 or 110 VAC voltage AC irrespective of the load. The inverters based on the PWM technology are more superior to the conventional inverters. The use of MOSFETs in the output stage and the PWM technology make these inverters ideal for all types of load. In addition to the pulse width modulation, the PWM inverters have additional circuits for protection and voltage control. Thank you.